Hello, my name is Leo. Today we're going to talk about digital logic. Digital or Boolean logic is logic applied to computer components, which are digital electronic circuits which handle digital signals. They can process, control, transmit and store data. Each digital signal has one of two values, 0 or 1, called logic levels. 0 logic level is also called low, false or off logic level, and 1 is also called high, true or on logic level. Logic family is a group of logic gates with compatible logic levels. One of the greatest improvements in the history of logic families was TTL, transistor-transistor logic family, which is built from BJT, bipolar junction transistors. And it was such a big improvement because it had 10 and later it got 20 fan-outs, which is number of inputs on only one output. And here you can see a table which represents these voltage ranges for each logic level, 0 and 1, for both input and output. And what if voltage is somewhere between this 0.8 and 2.2 volts in input? Then output cannot be predicted. So it can be either 0 or 1. One of today's most used logic families is CMOS logic family, so complementary metal oxide semiconductor logic family, which is used in digital circuits such as microprocessors and microcontrollers, and in analog circuits such as data converter and image sensor. Noise margin is appearance which appears between output of one device and input of other device, which is amount of noise that a circuit can withstand. So it is amount by which signal exceeds the minimum amount which is needed for proper operation. There are two main systems of logic: combinational and sequential logic system. Combinational logic is logic system where there is always the same output, Q, for the same given combination of inputs A and B. And it appears almost immediately after the inputs. It isn't immediately actually, because there is some time needed for signal to pass from inputs through electronic circuit to output. Logic gates are circuits used in combinational logic. They are idealized physical devices because there is assumption that there is no time needed for signal to pass through electronic circuit, although there is. And it is the biggest difference between combinational and sequential logic. Logic gates implement Boolean functions, which are functions such as AND, OR and other we'll talk about more. Truth table is table which says which is output for each combination of inputs. And it is used in combinational logic to represent that visually. Here are two basic logic gates, AND and OR logic gate. AND logic gate has this symbol, and in Boolean algebra is function A times B, where A and B are inputs. So the only case when output Q is equal to 1, so it is true logic level, is when both inputs A and B are equal to 1, because the only case when A times B is equal to 1 is 1 times 1, as we can see in this truth table. OR logic gate has this symbol, and in Boolean algebra is A plus B, so it is true. It has true output Q in any case except when both inputs A and B are equal to 0. NOT is actually not true logic gate because it only converts. It is also called inverter because it only inverts logic signal from 0 to 1 or from 1 to 0. So 0 is complement of 1 and 1 is complement of 0. As we can see this operation with some tilde, which is here marked. NAND is logic gate which has all of these truth table output values for Q. All of these are completely opposite, so complements of values for AND logic gate. And similar cases with NOR logic gate, which has all opposite values from OR logic gate. And here are two more complex logic gates from combinational logic, which are used very frequently, and they are very useful, such as XOR, also called EOR, which is exclusive OR. It excludes the case for both A and B inputs equal to 1, then output Q is equal to 0 and not equal to 1, such it is in OR logic gate. And here you can see this equivalent logic circuit for XOR, which is also equivalent to this Boolean algebra expression. And finally, XNOR has all of the opposite values from XOR. Now you've learned the basics of digital logics and about combinational logic. More about digital logic, about sequential logic especially, in the next volume of Digital Logic video. Thanks for watching and stay with us.